In the heart of the Pacific, far from any shore and hidden from human eyes, something immense is stirring. It is not a storm you could catch on a satellite, and not a wave that will ever break on a beach. It is a slow movement, a mass of warm water gliding silently beneath the surface, carrying with it the energy of 1,000 suns. While the world goes about its day, unaware, this deep pulse of the ocean is already preparing to turn the direction of the winds, the strength of hurricanes, and the fate of winter across continents. This is not the apocalypse. It is the awakening of the most powerful machine on our planet, and for once, we can watch it happen. To understand what is waking, you have to stop thinking of the Pacific as a body of water and start seeing it as an engine. The ocean and the atmosphere above it are not two separate things. They are two halves of one machine, locked together, trading heat and moisture in a slow exchange that sets the rhythm of the world's weather. The Pacific is the largest single surface on Earth, and the warmth it holds is the fuel. It helps to grasp just how much heat we are talking about. The warm pool gathering in the Western Pacific is the single largest store of heat anywhere on the surface of the world, a slab of ocean bathwater warm and bigger than entire continents, glowing with energy the sun has poured in for years. Nothing else on the planet hoards heat on this scale. When even a fraction of it is set loose, the whole climate feels the shove. In its calm, ordinary state, that engine is kept in balance by the wind. Steady currents of air called the trade winds blow along the equator, always in the same direction, from the Americas toward Asia. Think of them as invisible guardians, leaning against the sea day after day, herding the sun-warmed surface water steadily westward. Over years and decades, they pile that warm water up in the far western Pacific, near Indonesia, building a vast reservoir of heat that sits there unmoved, held in place by nothing more than the patience of the wind. There is an old way to picture this, and it works best when you make it precise. Fill a long bathtub, then blow steadily across one end. Water slowly heaps up at the far side, higher and warmer, leaning against the wall, held there only by your breath. The instant you stop, or even hesitate, all that gathered water comes sliding back. The Pacific lives in exactly that kind of fragile balance. An ocean's worth of warmth is stacked against the western edge of the world, and the only thing pinning it there is a wind that does not always hold. That is the secret hiding inside this story. The system is not built for stability, it is built for release. Sooner or later the guardians falter, the wind eases, and the reservoir that took years to fill begins, very quietly, to come home. When the trade winds finally relax, the ocean answers with something strange and beautiful, a messenger sent through the deep. It is not a wave like the ones we know, the kind that curls and crashes on the sand. What travels instead is a wave of warmth and pressure, hidden below the surface, carrying one of the most important signals on the planet. Scientists call it a downwelling Kelvin wave. The people who first sensed this had no instruments, only their nets. Centuries ago, fishermen along the coast of South America noticed that every so often the cold, fish-rich water they relied on would turn warm and barren, and that it tended to happen near Christmas. They named the warm intruder El Niño, the boy, a quiet reference to the Christ child. What felt to them like a curse on the season was the faint, surfacing edge of this very wave, the leading hint of a force that reaches around the world. To see what it does, you have to picture the ocean in layers. Near the top floats a blanket of sun-warmed water. Far below lies the cold, black abyss. Between them runs a thin, invisible boundary called the thermocline, the line where the warm world above meets the freezing world beneath. In the Western Pacific, where the heat has gathered for years, that warm layer reaches down as far as 650 feet. In the east, it sits much closer to the surface, letting cold water rise from below. Hold that boundary in your mind, because it is where the real drama plays out. The thermocline is no fixed shelf. It flexes and rolls like a taut membrane, lifting and sinking as the ocean breathes, and the warmth stored in the layer above it is the prize the entire system fights over. Press that membrane down in the east, and you smother the cold rising from below. Let it spring back up, and the chill returns. Everything that follows, every shifted storm and rearranged winter, begins with the bending of that one hidden line. The Kelvin wave is what happens when that western reservoir is finally let go. A swell of warm water hundreds of miles wide begins to roll eastward along the equator, pressing the thermocline down as it travels, dragging the warm layer deeper and choking off the cold water that normally wells up along the coast of the Americas. It moves with no hurry at all, crossing thousands of miles of open ocean over a span of weeks, an unseen pulse passing from one side of the planet to the other. By the time it arrives off South America, the sea there can stand half a foot higher than normal, swollen with the heat it has carried. The ocean has, in effect, mailed a letter across the world, and the message is that everything is about to change. For most of human history, all of this unfolded in total secrecy, noticed only long after the fact by fishermen whose nets came up empty. That blindness is over. The silent giant is now watched around the clock. Thousands of robotic floats drift through the Pacific, sinking and rising on a slow cycle, reading the ocean's temperature from the surface down through the first 1,000 feet and radioing the numbers home. Far overhead, satellites measure the exact height of the sea because warm water swells and stands taller. So, a rise of a few inches instantly betrays an ocean of heat hidden below. One sea-level satellite maps the entire ocean every 10 days, measuring the height of the water down to fractions of an inch, sensitive enough to feel the swell of heat rising from far below. In recent springs, it has watched exactly that. A warm bulge born in the far west, drifting east week after week, until the seas off Peru stood visibly higher than normal. From orbit, the warm Kelvin wave shows up as a long red bruise crawling east across the blue, and that is how forecasters catch this thing in the act. Months before any flood or drought ever arrives, what they are hunting for is not a headline. The tabloids grab a label, Super El Niño, and move on. The scientists reach for something quieter and more honest. A signal, a fingerprint in the data that tells them how hard the ocean is leaning this time. What has them watching so closely is not the name. It is that the sea was already running at record heat before this even began, so the warm wave is climbing on top of an ocean that was feverish to start with. That is what could push this event further than most. And this is the part that turns a quiet ocean story into something that touches everyone. The wave itself never reaches your city. What reaches you is its echo in the sky. When the ocean shifts its heat, the atmosphere has no choice but to answer. And that answer can travel from the middle of the Pacific all the way to your window. So follow the heat upward, out of the water and into the air, and watch how a single warm patch of sea quietly redraws the weather over half the world. The link between the ocean and the sky runs through the rain. Out over the warmest water, the air rises in enormous towers of cloud, thunderstorms stacked miles high. The chimneys through which the ocean breathes its heat into the atmosphere. Normally those towers cluster over the western Pacific, above the old reservoir of warmth. But when the Kelvin wave drags that warmth eastward, the storms pack up and follow it, shifting thousands of miles into the central Pacific, into skies that are usually calm. This drags a whole circulation off its hinges. Normally, the air rises in the warm west, races east high above the ocean, and sinks over the cool eastern Pacific, a vast closed loop turning steadily over the equator. As the warm water and its storms slide east, that loop weakens and stalls, and a pattern the planet had settled into for years simply comes apart. The engine has not just changed gears, it has started running backward. That shift is the hinge the entire planet turns on. The relocated storms pump heat high into the upper atmosphere in a brand new place, and up there flows the jet stream, the fast river of wind that steers the weather of the middle latitudes. Pouring all that heat into the jet stream works like dropping a boulder into a smooth current. The flow cannot continue undisturbed. It buckles and bends, throwing out wide loops and curves that ripple downstream for thousands of miles. Those ripples are how a warm patch of water near the equator ends up rewriting a winter far away. A single bend thrown into the jet stream over the Pacific can deepen into a storm track aimed straight at California, then swing north and leave a strange warmth over Canada, then dip again somewhere above the Atlantic. The ocean nudges the sky in one spot, and the sky carries that nudge around the globe. By the time it lands as rain over Los Angeles, or an oddly mild morning in London, almost no one thinks to connect it back to a silent wave that crossed the Pacific months earlier. When forecasters want to know where this might lead, they turn to memory, to the handful of giant events that older viewers will still recall for their floods and their ruined seasons. Those were the times the Pacific tipped over this hard, and they left deep marks: walls of rain along the American coast, drought on the far side of the world, a winter rearranged across continents. Held up against those ghosts, the present signal looks unsettlingly familiar, and yet it refuses to be a perfect copy. In the far western Pacific, this event already echoes the great ones of the past. But the Eastern Ocean has been slower to warm, lagging behind the script those giants followed. So even the people who watch this for a living are holding their verdict, waiting to see whether the wave finishes what it started or quietly loses its nerve. The signal is loud, the ending is still unwritten, but memory is a guide, never a guarantee, and here the story keeps its mystery. The atmosphere is not a machine that runs the same program every time. It carries a streak of pure chaos, an unpredictability that no amount of ocean heat can scrub away. Two great El Niño events can begin almost identically and still end up writing completely different stories, one drowning a coastline that the other leaves dry. The strength of the signal raises the odds of the extremes, yet it never quite locks them in. That is the honest heart of the science, and it is the first thing lost in the noise. A powerful El Niño does not hand us a future carved in stone. It loads the dice, tilting the planet towards certain outcomes, making the floods and droughts and wild winters more likely in the regions it tends to touch, then leaving the final roll to a restless, unrepeatable sky. The ocean changes the odds, but never the outcome. Still, the tilt of those odds traces a recognizable shape across the globe, and you can read the rough design of the change. Over North America, that buckled jet stream becomes a kind of storm highway, a strengthened current of air aimed at the southern United States. California and the southern states tend to find themselves under a long parade of storms, with heavier rain, swelling rivers, and a real risk of flooding wherever the water arrives too fast. Push north and the pattern softens. Across the northern states and into Canada, the winter often loses its bite, milder and drier than usual. The deep cold staying bottled up far away, while the snow that cities count on fails to fully arrive. The same event that hammers one coast with rain can leave another region strangely, quietly warm. Widen the view, and the fingerprints spread across the whole planet. The rains that normally soak the Amazon and the forests of Southeast Asia can falter, drying rivers and priming the land to burn. Half a world away, deserts that almost never see water can suddenly bloom after freak downpours. The monsoon that waters much of Asia can arrive weak and late, a quiet shortfall that touches the food of hundreds of millions. None of it looks related from the ground. All of it traces back to the same warm wave in the same ocean. Out at sea, El Niño plays its old trick with the hurricanes, a seesaw balance between two oceans. In the Atlantic, it tends to raise high winds that tear young storms apart before they can grow, calming the basin that most threatens the United States. In the Eastern Pacific, the opposite unfolds, as warmer water and gentler winds let storms there swell larger. And the reach does not stop at any coastline. The same shift can dry Australia and Indonesia toward drought and fire, soak parts of South America, and weaken the great seasonal rains that billions of people depend on across the far side of the world. One warm wave in the Pacific, exhaled over every continent at once. It is tempting, faced with all of this, to slide toward dread, and the internet is glad to help. The loudest voices online will tell you this is the end of something, a planet breaking, a doom to brace for. That story is wrong, and it misses what is genuinely remarkable here. This is not the world ending. It is the world working, a vast natural rhythm that has been swinging since long before there was anyone to fear it, and one we can finally see coming with months to spare. That last part is the quiet miracle. A farmer can choose a hardier crop, a city can ready its storm drains, a water manager can plan for a wet winter or a dry one, all because the ocean tipped its hand months in advance. The same science that reveals how fearsome this system is also hands us the time to meet it calmly. Fear is the easy response to a force this big. Preparation is the smarter one. The real challenge is subtler and far more interesting. Every great El Niño of the past arrived in a world that held more or less steady around it. This one is rising in an ocean that is itself growing warmer year after year, which means each new event pushes into conditions that have never quite existed before. The old patterns still rhyme, but they no longer repeat cleanly. We are running an experiment with no exact precedent and watching the results come in live. We have done a smaller version of this before, with hurricanes and eruptions and floods, turning raw fear into forecasts and early warnings. El Niño is the largest test of that habit yet, a chance to meet one of the planet's great forces with open eyes instead of dread. If there is a single lesson buried under all of it, this is the one. Nothing on this planet happens in isolation. A wave you cannot see, in an ocean you may never visit, can decide whether it rains on your city this winter. El Niño is the clearest proof we have that the Earth is not a scattering of separate places, but one connected system, breathing as a whole. The ocean does not need to roar to remake the world. Sometimes all it takes is a small shift, 1 degree of extra warmth, a single silent wave traveling through the darkness of the deep. We tend to imagine catastrophe as something loud and sudden, yet the most powerful force on our planet moves slowly, quietly, and almost entirely out of sight. There is something humbling in that. We watch the sky for our storms and scan the horizon for danger, while the shift that shapes the whole season is decided far beneath the waves, in water no sunlight will ever reach. The largest movements in our lives are often the ones we never see happen. We are not separate from that system, watching safely from the outside. We live inside it, downstream of every wave. The same delicacy that lets one warm current reshape a winter sits behind the calm, ordinary weather we rarely stop to notice. Learning to read the giant is how we learn to live alongside one. So the next time you hear the name El Niño, do not think of a weather forecast. Think of the heart of the Pacific changing its beat, and the whole world, whether it knows it or not, holding its breath. If a hidden world we almost never think to look at pulls you in, there is another one waiting in plain sight, much closer than the deep Pacific. We have sent probes to Mars, to Pluto, to the very edge of the solar system, and yet barely anyone has looked in one simple direction. We finally did, in our video on what is directly above and below the Sun. Go watch that one next.